in this chapter, I had mentioned to you guys that we were going to soon get into a third dimension with a third variable, and that is today. Today we are going to do 3.5, graphing linear equations in 3 variables. So now we no longer have just x and y, we've got x, y, and z. And it's going to take a little while to get used to because our axes are going to change. You're used to seeing an axis like this. This is your x-axis, this is your y-axis. That is no longer going to be true when you're looking at an x, y, and z. If you look here, you can see that here is going to be the x-axis, here is y, and here is z. This is x in the positive direction. If I wanted to go in the negative direction, I would be going out this way. This is y in the positive direction. If I was going y in the negative direction, I would be going to the left, which normally would be our x's, so that's why it's going to be a little bit more difficult. And this is z in the positive direction, so if I wanted to go z in the negative direction, I would be going down, which would normally be your y. So you've got your x, you've got your y here, you've got your z up there. If I am plotting the point 2, 3, 5, this is the x, this is the y, that is the z. So if I want to go right, or not right, if we want to go on the x-axis 2, I start at the origin like always, and I go 1, 2. There's where my x coordinate is going to be. Then I have to move from there to find y is 3. Well, here's my y, so I go right 1, they're actually a little bit bigger, 1, 2, 3. So now I've gone x2, y3, and then my z is 5. So I'm going 1, 2, 3, 4, 5, and that is going to be the location of your point 2, 3, 5. These are the steps that you're going to take to get there. You do not actually plot those points. If I'm plotting just this one ordered pair, for example, if I was plotting 2, 3, I would go right 1, 2, up 1, 2, 3. The only thing that I would actually plot down on my paper is that last point. Same thing is true here, but now you've got 3 things. You've got to go x, y, and then up for z. Alright, so let's look at our next point. We've got 4, 5, 2. Again, we start at the origin. We're going to go right on the x-axis, 1, 2, 3, 4. Then I want to go to the y, 5. Here's the y, so I'm going to go 1, 2, 3, 4, 5. And then last, our z is 2. So from z is going up and down. We're going to go up 1, 2. So this would be the final location of our point 4, 5, 2. To get there, we had to do our x, and then our y, and then our up 2. So this is going to be in a 3-dimensional space. What I want you to do now is try to graph these 3 points on your own. Press pause, and then when you're done, check to see if you got them in the right spots. Okay, let's see how you did. For the first one, we've got 2, 3, 4. We go 2 in the positive direction on x, 3 in the positive direction on y, and then 4 up the positive direction for z. So this should be the location of your first point. What's difficult about this, what's different than your normal x-y axis, is that you don't have a nice clean grid that you can put a point on every intersection. We see that this is the distance between our tick marks, so we've got to kind of guesstimate once we're off that axis. So I'm going 2. If I'm going right 3, I'm going to kind of guesstimate where that same distance is going to be, and then up 1, 2, 3, 4. Again, I'm guesstimating that that's the same distance as that tick mark. So we go to our second one. We start at the origin. Now since I have a negative 5x, I'm going to go in this direction. I'm going to work back 5. We've got a positive 3, so we're going to go right 3. We've got a positive 4, so we're going to go up 4. And our last point, we've got a positive x, so we go positive x3, a negative 4y, so instead of going right, we're going to go left 4, a negative 2z, so I'm going to go down 2, and there's the location of your last point. So we've got our 3 points. Here's 1, here's 2, and here's our third one. Okay. So if that is graphing a point, there is a difference between graphing a point and graphing this three-dimensional, three-variable equation. The way that you graph this three-variable equation is to find all of the intercepts. Well, I know that if I want the x-intercept on a normal graph, the y value is 0. And if I want the y-intercept, the x value is 0. So here, if I want to find the x-intercept, I know that the y is equal to 0, and I know that the z is equal to 0. So when I'm finding the x-intercept, I'm ignoring the y, I'm ignoring the z, because those have values of 0. So I have x is equal to 6. Just like before, anytime you have an intercept, you always want the coordinates at that point. So this is 6, 0, 0. When I want the y-intercept, I know that the x-coordinate is at 0, and I know that the z-coordinate is at 0. So when I look at the equation, x is gone because that's 0. 2 times 0, that's gone. So I've got a negative 2y equals 6. Y is a negative 3. And yes, you must give me the coordinates. The x is 0, the y is a negative 3, and the z is 0. And last, if we want our z-intercept, we know that our x is 0 and our y is 0. So when we look at our equation, x is gone, y is gone. I'm left with 2z is equal to 6, therefore z is equal to a positive 3. So the coordinate of that point is 0, 0, 3. Must give me the coordinates. If you don't give me the coordinates, you're going to lose points. So we've got an x-intercept of 6, so we go on the x-axis, positive 6, 1, 2, 3, 4, 5. There would be the location of 6, 0, 0. Then we want our y-intercept. We've got a negative 3. So here's the y-axis. We go left 1, 2, 3 from the origin. And that point is 0, negative 3, 0. And our last one is our z-intercept at 3. So we start at the origin, 1, 2, 3. And we have 3 points. We connect those 3 points. And you see your three-dimensional equation there. So just don't get confused. There is a difference between graphing an ordered pair, which is just one point, and graphing an equation. In the equation, you have 3 points. You have the x-intercept, the y-intercept, and the z-intercept. You plot those 3 points, which will fall on each of the axes, and then connect your points. So we have one more of these examples. If we want the x-intercept, we take negative 2x, we set it equal to 12. And we've got x is a negative 6, therefore we've got our x-intercept at negative 6, 0, 0. If we have our y-intercept, we've got 3y equals 12. Y is 4, so we've got 0, 4, 0. And this is exactly what I should see on your quiz and test for showing work. Negative 4z equals 12, z equals a negative 3. So this is 0, 0, negative 3. We've got our 3 points. We start with the x-intercept. Here's my x-axis. I want the negative 6, so I see that this is the negative direction. 1, 2, 3, 4, 5. That would be the location of our point, negative 6, 0, 0. Our y-intercept, we look at our y-axis. We want a positive 4, 1, 2, 3, 4, 0, 4, 0. And our last point is our z-intercept of negative 3. Here's the z-axis, here's the negative direction. So we go down 1, 2, 3. There's our point 0, 0, negative 3. We've got our 3 points. We connect our 3 points. And there is the graph of our three-variable equation. Next. Alright, so we plotted points, we graphed equations. Now we are going to write an equation in function form. So you're used to f of x being the function form so that it's written as a function of x, a function of y. Now we want to write the equation as a function of x and y. It's a lot easier than it sounds. All this means is that we want to solve for z. Then we're going to evaluate it. This is the x coordinate, this is the y coordinate. So on your quiz and test, when it says evaluate the write the equation as a function of x and y, all that means is to solve for z. So if I want to solve for z, I've got to move that 9x over. I've got to move that 12y over. So now I'm left with 3z equals a negative 9x plus 12y plus 30. Then I want z by itself, divide all three pieces by 3. Z equals a negative 3x plus 4y plus 10. And when it says write as a function of x and y, just like f of x, but this time we have got f of x and y is equal to a negative 3x plus 4y plus 10. Remember, this is what you are plugging in. And I have an x and I have a y variable. That's how I know there's an x and a y here. So that is the equation of our function in terms of x and y. Now I want to evaluate for negative 2, 2. This is the x coordinate, that is the y coordinate. Just like before, we evaluated for an f of x. Now we have two things to plug in. We've got negative 3x plus 4y plus 10. All I did was use that equation. We are plugging in an x value of a negative 2. We're plugging in a y value of a positive 2. That comes from there. So we've got 6 plus 8 plus 10, 14 plus 10. When we evaluate, we get 24. Alright, we have one last thing for our notes for today, and it's a word problem. A family is planning a vacation at a resort. The airfare is $1,200, lodging is $120 per night, and family style meals are $40 per person. So we've got three different things going on here. Airfare is $1,200, lodging is $120 per night, and meals are family style, which is $40 for each meal. We have two variables here. One, x is going to be the number of nights, and y is going to be the number of meals. We are paying just a flat rate of $1,200, so that's not going to have any variables. There's no unknowns there. We don't know how many nights we're staying, so that's why that's our first variable. We don't know how many meals are going to be eaten, so that's going to be our second variable. What I want you to do is press pause and see if you can come up with an equation that would represent everything in one. You should have your two variables, your x and your y, and a third variable for what it's equal to. Okay, if you didn't get before, hopefully it makes sense now. I used C for total cost, $1,200 for your flat rate, $120 for every night, and x is the number of nights, $40 for every meal, and y is the number of meals. What we're going to do is we're going to use this equation to find different amounts that we can have. So different ways that we can organize how much money it's going to cost. So our y is the number of meals, our x is the number of nights. So if I have 2 meals and I stay one night, how much is it going to cost? Well, we look at our equation. We said that we were going to have one night, so that's 120 at 1, and we're going to have 2 meals at $40. So we've got 1,200 plus 120 plus 80. That's going to give us $1,400 is going to be the total cost. Press pause, and I want you to fill in the remaining values in your table. Okay, check the values in your table to make sure that you got everything correct. Remember, these are the numbers you're plugging in for y, these are the numbers that you're going to plug in for x. And our last question is, describe the circumstances for when the trip is going to cost $1,760. When you find that value in your table, you see that it's going to be for 3 nights and for 5 meals. and then we're done.